What we do here is go back.
Hello, welcome back to Mr. Anderson's Algebra 1 Lessons. Today, we are going to investigate how to solve equations with square roots. Got a fly in here, so like the video just because there's a fly in here, but whatever, we're doing math and we're having fun. Doesn't matter what's in our way, we're going to stay positive. So we're going to talk about solving equations with square roots. Okay, so typically what these equations look like is usually it's a single variable equation. A lot of times they're quadratics, and you have to, in order to isolate the variable, you have to square root either side or both sides. And so I just wanted to go over a couple examples. They're pretty straightforward. The first one, we'll start small. We're going to start with a squared is equal to 49. And the basic idea here is, actually there's a lot of things going on at this time. We're actually learning about using the order of operations and inverse operations at the same time, and then learning the inverse operation you need to use in order to isolate that variable. In this case, we have a squared. So the inverse operation of a squared term is the square root. So I square root this side. But if you remember, algebra's golden rule, right here, algebra's golden rule, what you do to one side of the equation, you have to do to the other side. So in this case, we have to square root the a squared, and then we have to square root the 49. Lucky for us, square root of 49 is a perfect square, and a is just equal to 7. But wait a minute. Didn't you remember last time we did a square root activity, we learned that the square root is really asking us this question. What number multiplied by itself equals 49? And in this case, that would be 7. So positive 7 is true. But hey, Mr. Anderson, I remember back in like 7th and 8th grade, they said negative 7 times negative 7, if I multiply those together, that does equal 49 as well, Mr. Anderson. And the answer is yes, it does. So this is not just a equals positive 7, it's also a equals negative 7, just for this reason. Because the square root is asking us what number multiplied by itself is equal to the number inside the square root. So I hope that helped you out a little bit, because some people might get a little confused. Like me back when I was in 7th grade. I didn't know what the heck was going on. So now I do, and I can help you guys out. So that's that example. Let's take a look at another one. Let's try to increase the difficulty a little bit here. Let's try 10 times b squared equals 810. So this time I upped my game a little bit. Now I got a number multiplying by the variable squared, and it's equaling something on the other side. So this is now what we call a two-step equation, or a multi-step equation, and we need to do something before we square root. And so this all goes back to the inverse operations and the order of operations. What I see going on here is I see that the 10 is being multiplied by the b squared, but I want to solve for b. So if they're multiplying, I need to do the inverse operation of multiplication, which everybody knows is division. So I'm actually going to divide this side by 10, and I'm going to divide this side by 10 as well. Okay? Now a lot of you teachers back in the day said, oh, 10 divided by 10 cancels each other, which they do, but that's not technically what you need to say. 10 divided by 10 is actually simplified, it's actually equal to 1. So there's actually this invisible 1 being multiplied to the b squared. Okay? And so then after that, I have the b squared, and I just take 81 divided by 10, which is, or 810 divided by 10, which is 81. That's really nice, because now, from the top example, all we had to do was square root. Well, now I'm to that exact point where I just square root. Square root both sides. Those two terms cancel each other out. B is equal to, don't forget, plus or minus the square root of 81, which is a perfect square, and the square root of 81 is 9. Yeah, coming back at you. So that is my answer right there. Let's do one more before I send you on your way. And this is going to be the final example. And let's take a look at something a little bit more extreme here. So let's take a look at 10 times x squared minus 7 equals 33. So now in this example, we added one more thing. So now we have 3 steps in order to get the x by itself. And so like the order of operations and inverse operations, we're looking for the operations that we see, and then we are going to do the opposite to move them across. Now, in a later video, I'm going to talk about the inverse operations and the order of operations a little bit more. But for now, we're just trying to get the x by itself and learn more about the square root. So in this case, I see that I have a subtraction sign. And we know that the subtraction is, the opposite of subtraction is addition. So I'm going to add 7 to this side and to this side. I'm left with 10 times x squared equals 33 plus 7, which is 40. Now the reason I'm doing this, you guys, is that I need to balance my equations. You know, life and the universe and math are all about balance. And I'm simply just balancing the equation and simplifying at the same time. Now that I'm here, it turns to what we did up here, where I had to divide. So now I need to divide by 10. So I'm going to divide by 10 here. And those do not cancel, but they leave me with x squared. Okay. 40 divided by 10, that's just equal to 4. And we simply just square root both sides here. X squared cancels out with the square root. And I have the square root of 4, which is a perfect square again. So x is equal to plus or minus 2. So there we go. Hit me up with questions in the comments. Like, subscribe, share, spread this around. Math is a beautiful thing. It's a worldwide language. It's a universal language. And hit me up for any questions if you'd like it. Again, this is Mr. Anderson's Algebra 1 lessons. I hope you have a great day. And thanks for mathing. Thanks for mathing with me today.